All right, this discussion is going to be about finish on the ends of the fasteners you're trying to read ultrasonically and the transducers. Now here we have an example of three fairly large studs. This looks like an M50. This is an M42, and that looks like an M30. Now you can see on this one, on the large one, this is a saw cut surface. Typically, the rougher the surface, the more remove and replace area you're going to get on the bolt, on the box when you start reading try to read the reference lengths and the stretches. But however, this bolt, if you looked at it crosswise, it's a perpendicular surface to the axis of the bolt, and the surface is not that bad. It's a saw cut, but it's okay. And we should be able to read this bolt with fairly good repeatability. The other side of that is the bolt stretches a lot because it's a long fastener, and the error on the remove and replace caused by the roughness of the surface should still be small compared to the total amount of stretch that we're reading. This M42 has got a perfect finish on it. It's milled. It was put in a vertical miller and slowly cut across the face, so it's very smooth and perpendicular to the axis. Perfect finish for removing and replacing the transducer. The next stud is an as-received galvanized fastener. It looks like the surface was machined flat after the stud was made and galvanized. Now, we can read through the galvanized. That's not a problem. The problem is if that the surface is smooth and in one piece. The ultrasonic signal, the ultrasonic transducer really doesn't care much about the coating as long as it's thin compared to the length of the fastener. The thing it cares about is that it's not that rough, because if it's rough and bumpy, you're going to get remove and replace error. Now, I've seen galvanized fasteners that have big chunks of zinc hanging off them. You can't read those. What I tell people on galvanizing is if it's a rough finish, take a green Scotch-Brite wheel to it and smooth it off, or even a fine sandpaper wheel to it. I've used battery drills and little disc attachments for a drill with fine sandpaper on them and smoothed it off, and you can get a nice coating. Now, to read these, here we have our transducer. Now, the transducer is just that. It's both a speaker and a microphone for our ultrasonic signal. It sends the pulse and it receives the pulse. And it does that by attaching it to the stud and then exciting the transducer with our ultrasonic box. Now, what you want to do is you put a small drop of couplant on the transducer. Doesn't take much. All we're trying to do is get liquid interface between the transducer and the stud so that it can get the ultrasound from the transducer into the material. And I always recommend you wipe the surface of the stud off to make sure there's no dirt or dust or anything that's going to get in the way and raise that transducer off of the surface of the bolt. Then we rock the transducer onto the stud, center it, and the thing here is to use the largest transducer that fits onto the diameter of the bolt. Now, this is a 3/4 inch 5 megahertz transducer, 19 millimeter transducer, and it's easy to center by feeling with your fingers onto the stud. Now you're ready to read. You can read that. You take it off, and when you come back to read this, you want to wipe it off the end of the bolt off again. Make sure that it's clean, no debris left on it. Put a drop of couplant on and rock it onto the bolt. Center with your fingers and read. You should find that technique gives you good repeatability. Now you can see you do the same thing with all the bolts. Rock the transducer around with the couplant, locate it with your fingers, and go. Now this particular transducer is just about the right diameter for this galvanized stud, and it works great. One point here is on this galvanized stud or on any bolt is that, remember, these are rolled threads, so you're going to have a little burr or raised area where the thread rolling process extruded the material out to the end of the bolt. You got to make sure your transducer is inside that rolled surface, otherwise it's not going to hit the end of the fastener. So that's on large fasteners. Now we're going to go to some smaller bolts and look at the end finish on small bolts. Okay.